In this lesson, we're going to learn how to simplify square root radicals. Let's take a look at a situation. 3 students are working on a math problem. They came up with 3 answers that look distinctly different. They argue for a little while over who's right, and then they decide to type each of them into the calculator. When they do that, they find that each of those radicals comes out to be the same decimal. They're equivalent. So how do you go from the square root of 72 to 3 square roots of 8 to 6 square roots of 2? Well, let's talk about that today as we learn about simplifying square root radicals. To simplify square root radicals, we should follow the following process. The first step is to find the largest perfect square that evenly divides the radicand. Step 2, rewrite as 2 radicals. You'll have the square root of a perfect square times the square root of a non-perfect square. Then, finally, we will take the square root of the perfect square and keep the non-perfect square in the radical. Let's take a look at some examples to see what this looks like and how the process is done. Let's begin with our steps on the side, and our first example is to simplify the square root of 18, or what we call rewriting it in simplest radical form. My first recommendation is to keep a list of the perfect squares handy. These are the numbers that you get by squaring. For instance, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. Keeping that list handy makes this process much simpler. We're looking for the square root of 18. Look at the list up above and identify where the 18 would be located. It would be here between the 16 and the 25, but it's not there. We need to go down the list, starting where our first arrow is, and find the largest one of those perfect squares that evenly divides or goes into 18, and we check them one at a time. Does 16 go into 18? We could check in our calculator 18 divided by 16. We see it does not go in evenly, so that one is out. How about 9? Does 9 go into 18 evenly? We could check in our calculator 18 divided by 9, and we see that it goes in 2 times. 9 is the largest perfect square that divides the radicand 18. In fact, 9 times 2 is 18. So I will rewrite the square root of 18 using step 2 as the square root of 9, there's the square root of the perfect square, times the square root of 2, there's the square root of the non-perfect square. We know that the square root of 9 is 3, and we keep the square root of 2. The square root of 18 can be rewritten as 3 square roots of 2. That is called the simplest radical form. We can confirm that the square root of 18 and 3 square roots of 2 are equivalent by typing them both into our calculator. Notice that the decimal approximation of each is the same, which means that the 2 radicals that I typed in, square root of 18 and 3 square roots of 2, are equivalent. Let's try another example. This time, we want to rewrite the square root of 27 in simplest radical form. Once again, we look at the number line at the top, which contains the perfect squares. 27 is located here between 25 and 36. We go down the list to find the largest perfect square that evenly divides 27. We begin with 25. Does 25 go into 27? We could check in our calculator. 27 divided by 25? No, it does not. Does 16 evenly go into 27? Once again, we could check in our calculator. 27 divided by 16. We see that it does not go in evenly. How about 9? Does 9 go into 27? Yes, it does. 9 goes into 27 3 times. 9 times 3. Now, step 2. We rewrite as 2 radicals. We change the square root of 27 to the square root of 9, the perfect square first, times the square root of 3. We know the square root of 9 is 3, and we keep the square root of 3 from the second radical. The square root of 27 can be rewritten as 3 square roots of 3. 3 square roots of 3 is called the simplest radical form. Again, we can verify this by looking at our graphing calculator. If we type the square root of 27 and 3 square roots of 3, we see that the decimal approximations are the same. This confirms that the 2 expressions are equivalent. Here's one for you to try. Can you rewrite the square root of 24 in simplest radical form? Please pause the video here and come back when you're ready to check. Let's compare answers. We look at the number line and find where the 24 would be located. 24 would be located between 16 and 25. We then go down the list and look for the largest perfect square that evenly divides 24. Does 16 go into 24? No, it does not. Does 9 go into 24? No, it does not. Does 4 go into 24? Yes, it does. 6 times. 4 times 6 is 24. We now work on step 2, rewriting the square root of 24 as two radicals. The perfect square is 4, so I'll put that first. The non-perfect square is 6, so I'll put that second. The square root of 4 is 2, and we keep the square root of 6. The square root of 24, written in simplest radical form, is 2 square roots of 6. Again, we can confirm this by looking at our graphing calculator to see if the expressions are equivalent. When we type them in, we see we get the same decimal approximations, which means the two expressions are equivalent. Let's try another one. Can you rewrite the square root of 125 in simplest radical form? Please pause the video here and come back when you're ready to compare answers. Let's compare answers. We look on the number line to identify where 125 would be located. It's here between 121 and 144. We have a lot of perfect squares to try. We always start with the largest and work our way down the list. We first check 121. It does not go into 125. We check 100. It does not. 81 does not, 64 does not, 49 does not, 36 does not. 25, however, does. 25 times 5 is 125. We rewrite the single 125 in the square root as two radicals, square root of 25 times the square root of 5. The square root of 25 is 5, and we keep the other square root of 5. 5 square roots of 5 is the simplest radical form. Again, we can verify that these expressions are equivalent by typing them into our calculator. If we get the same decimal approximation, we know that we have equivalent expressions. Let's try one more. Can you rewrite the square root of 108 in simplest radical form? Please pause the video here and come back when you're ready to compare answers. Let's compare answers. We look for 108 on the number line. It's located between 100 and 121. We go down the list to find the largest perfect square that evenly divides 108. We go one at a time until we find that number that actually works, and that number is 36. 36 goes into 108 3 times. 36 times 3 is 108. Step 2, rewrite as two radicals. The square root of 108 is the square root of 36 times the square root of 3. Step 3, take the square root of the perfect square and keep the non-perfect square in the radical. The square root of 36 is 6, and the square root of 3 will remain. 6 square roots of 3 is the square root of 108, written in simplest radical form. We can verify that these expressions are equivalent by typing them into our calculator and comparing the decimal approximations. If the decimal approximations are the same, then the expressions are equivalent. Now that we know about simplifying square roots, let's go back to the situation that we had at the beginning of our video today, where we had 3 students who were working on a math problem, and they came up with 3 answers that looked distinctively different. But when they typed them into the graphing calculator, they found that all 3 answers were equivalent. Which of them is the best? Let's have a look. We know the square root of 72 is simply not simplified, so that was not written in simplest radical form. That answer is certainly not the best. How about 6 square roots of 2? Let's see what that student did. Let's have a look at their work. That student looked at the number line and went down looking for the biggest perfect square that goes into 72. When the student did that, they found that it was 36. 36 times 2 which gives us 6 square roots of 2. So that answer looks pretty darn good. How about the student in the middle who came up with 3 square roots of 8? Remember, it can't be perfectly wrong because it's equivalent to the other 2. So let's see what they did. That student looked at the number line and looked for a perfect square that went into 72. That student identified 9 times 8. 9 times 8 is 72. So they wrote 9 and 8 in the square roots, coming up with 3 square roots of 8. The thing is, this student did not pick the largest perfect square. The largest perfect square was 36, not 9. Is there a way to recover from this point? Well, notice the square root of 8. If I look at 8, 4 goes into 8, 4 times 2. So I can actually rewrite that square root of 8 as the square root of 4 times the square root of 2. We know the square root of 4 is 2, so we have 3 times 2 square roots of 2, or 6 square roots of 2. The simplest radical form is 6 square roots of 2. The lesson to be learned here is this. If you want to do this with the least amount of work possible, it's always beneficial to find the largest perfect square that divides the radicand evenly. If you find any perfect square, as the student in the middle did, then you'll have to simplify again. You can do it in one step if you find the largest perfect square, as the student on the right-hand side did. Now you know everything you need to know in order to simplify square root radicals. Remember, you can learn more about simplifying square root radicals in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.